Welcome back, class. Today we're going to do a standard physics problem called car on a banked curve. This is about a car going around a curve that is banked up at an angle. And the question really is usually something about assuming that you don't have to have any traction on the tires, no friction to keep the car from sliding down the curve. How fast should it go for a given radius of turn so that it stays exactly on the road and doesn't slide out or slide in? So, of course, we look at our free body diagram, and you can see we have mg facing downwards, and we also have the normal force perpendicular to the road facing out. The interesting thing here is that you can do a little geometry, and you can find that theta, the angle of the bank, is also the same theta as the angle of the normal force from the vertical. So basically the trick here is, let's see, I'm going to grab myself a good color. Oh, I need a line. Is that we take the normal force and we break it into two components. One component that's vertical and one component that's horizontal. Okay, so we have basically a vertical component. Oh, geez. Sorry. A vertical component and a horizontal component. So if we break it up like that, we can see that since the car is neither going down or up, the sum of the forces in the up and down, the vertical direction, is 0, which basically tells us this piece, this vertical piece right here, has to equal mg. Alright, so this piece right here is mg. And you can also see that this is equal to the normal force, I'll call it F sub n, there's the normal force, times the cosine of theta. Then we have this piece up here. Well, this is the piece going to the left. That's the piece that has to do with the fact that you have a centripetal force pulling the car in order to make the turn. So that piece there is just going to be our old mv squared over r. Right? That's our centripetal force. But that's equal to Fn sine theta. Now here's where the little trick comes in that puts this whole piece together. Okay, so you need to know a little bit of trigonometry. Let's see. The sine is the opposite over the hypotenuse. And the cosine is the adjacent over the hypotenuse. So what is the sine over the cosine? Well, that's going to be equal to the sine divided by the cosine. So that's the opposite over the hypotenuse divided by the adjacent over the hypotenuse. Well, remember, division of fractions, you just invert and multiply. So that becomes the opposite over the hypotenuse times the hypotenuse over the adjacent. See, the hypotenuses cancel, and you get the opposite over the adjacent. If you look at your trigonometric functions, you'll realize that that is equal to the tangent. So sine over cosine equals tangent. this is the trick we're going to use to simplify this whole situation, because what we're going to do is we're going to take this equation over this equation. So we're basically taking mv squared over r divided by mg equals fn sine theta divided by fn cosine theta. You see, because this equals this and this equals this, we can say that this one over this one equals that one over that one. We're just dividing equals by equals. So if we do, let's see, I'm going to change my color for a minute. How do I do that? Just grab this one. All right. So let's see. Those masses cancel. Those normal forces cancel. This r can actually go down here because v squared over r divided by g is the same as v squared over rg. So we have here v squared over rg equals, and we're left with sine over cosine, which remember is tangent, equals tangent theta. And that's it. That's our magic formula. You're not going to be, I don't think you're given that formula in the AP test, so you're going to want to be able to either memorize it or derive it like this and remember where it comes from. But let's go ahead and use it to solve a problem. So let's see, v squared over rg equals tan theta. Let's go to a new page, and I'll pause it for a second. Okay, so here we are on a new page. We've got our formula, v squared over rg equals tan theta, and we're going to do example 8 on page 144. If you need to pause it to go get your book, go ahead. I'll read the problem for you. It says, the Daytona 500 is the major event of the NASCAR season. It is held at the Daytona International Speedway in Daytona, Florida. The turns in this oval track have a maximum radius at top of r equals 316 meters and are banked steeply with theta equal 31 degrees. Suppose these maximum radius turns are frictionless. At what speed would the cars have to travel around them? Okay, so let's see what we've been told here. I'll grab my pencil. We've got r equals 316 meters and theta equals 31 degrees. We're trying to find v. No problem, right? V squared over 316 multiplied by 9.8, which is g, equals tangent of 31. So let's see, we can multiply both sides by 316 times 9.8. We have v squared equals 316 times 9.8 times the tangent of 31. Okay, that means that v equals the square root of 316 times 9.8 times the tangent of 31. Okay, I'll pause it for a second and do this calculation. Okay, we get an answer. This is equal to 43 meters per second. That's all there is to it. So, if you understand all that, you should be all set. Basically, we're really just using this one equation right here, but I would like you to understand where it comes from. But this equation will allow you to solve the problems that I'll assign for you. Let's just go back for a second and remember where it came from. Okay, so basically, if you take the normal force, we can divide it into two parts. The horizontal part, which just is equal to mv squared over r, and it's also equal to normal force times the sine of theta, since it's the opposite of theta, And then there's the, by the way, theta is down here. And then there's the vertical force, which is what balances out mg. So it's equal to mg is the normal force times the cosine of theta, because it's the adjacent. So now all we do is we take this equation divided by that equation. See, we've got this one on top, that one on bottom. Cancel out the m's, drop the r down, cancel out the normal forces, and the sine over cosine becomes a tan, and there you have your formula. That's all I've got for you today. So I hope you enjoyed it and learned it, and I'll see you soon. Bye.